お前はもう死んでいる。何？
Now that I'm recording, we can see our network. But before actually anything, I wanted to get some information from you guys about your TouchDesigner journeys. So for me, it's been about 2 years. I was obsessed with this software, and I decided that I wanted to try to share the knowledge and teach it. And yeah, I've been in motion graphics for like 10 years now, mostly in After Effects and Cinema 4D before I discovered TouchDesigner. And then I really just fell in love with the software and creating networks within TouchDesigner. So that's a little backstory for me. Alrighty. So I prepared this file for you because I was going to teach you how to make this audio component I have here. But I went through a demo, and to do it all, it took like an hour to get to like any actual visual. So I've made a little preview for you in the software of how to work it. And oh, that is not what I meant to do. I just wanted to turn the grid off. I find it a little cleaner. So the way this course is going to work, we're going to basically start from almost scratch and kind of build our network and see how this audio component I've provided to you can be utilized to make animations in all sorts of ways. The interface I have set up for you is how I like to work in the software, where it's split in between the two halves. And so we can close this panel, and TouchDesigner will often look like this when you open with the jelly beans, and it's doing an infinite thing because my only top that is active is this NDI in. But if this out top is active, this is kind of what it looks like with the jelly beans when you first start it, and I find it quite confusing to work like this. So I like to right click and hit display and then detoggle the background top. And then in the top right, there's this little arrow, and it's our pane options. And then we can go in there and split it left and right, and it'll just create a duplicate of what you have active at the start. But if you click on the arrow to the upper left here and then go to panel, it's gonna be blank. But if we click project 1, our panel is set so in such a way it refers to our final out, which is over here in the chain. If I'm going too fast for anyone, feel free to stop me and inject with a question. But there's lots to get through, so I will keep going. One of the other things about the TouchDesigner interface that is kind of unique is the like zoom GUI. And so right now we're in 2 components deep. A component is kind of like a pre-comp in After Effects or like a group in Blender. And if I hit U on the keyboard, we go up a level, and then I hit it again, and we go up 1 more level. And then you can see that in this project container, it's referring to our main out that's within this main component, and this node at the very end of our chain is basically our master out of what is happening. And so knowing where you are in the network can be complicated. But if you refer to the status bar up here. Hello. Oh, no worries. All good. Did you guys grab the file?
The zip file?
Yeah.
No.
No. That's okay. I have a USB. There's a base file.
Yeah, I was thinking about
You guys missed the
weekend.
intro, which was just
Part of it.
I asked everyone what their journey with this software was
Yeah.
and how experience
Was eye-opening. Yeah, super inspiring, and also really impressed with the crews that are running all shows and installations and bowling. Right? Everything sounded and looked so good.
Okay.
Oh, cool. Oh, sweet. That's good. Next weekend? Or the weekend after? 2 weeks. Yeah, cool. Exciting.
And so we're gonna go over how to kind of use this audio component to drive visuals, and I have a few examples I've built for you all in here. And this is what's called a switch top, and basically it'll take as many inputs as you want and gives you a value to switch between them all. So the first one is like a 3D based audio-reactive animation that is in the SOP world. I will get into that a little later. And then our second visual that we're gonna try to do is a reaction diffusion based one, which is one of my favorite TouchDesigner things. This is all based on feedback loops. And I think they just are really cool and interesting patterns to utilize. And then this is audio spectrogram animation. And we probably won't have time to get to these other two, but I included them in there so you can take a look at a later date. But this is a classic kind of camera tunnel scene. So it's an infinite tunnel and a torus going in a loop. And it's actually reacting to this nice ambient set that my friend Paul is playing right now. And you can kind of tell. I have a little XLR cable in, is how I'm getting the audio. Then our last scene is an instance-based scene, which is a pretty core function in TouchDesigner to make replications. And you can do all sorts of cool stuff with instancing. So where you see like all these crazy point cloud stuff on TouchDesigner, it's usually through instancing. And yeah, so before we do anything, we're gonna wanna save out a project so that we're not overwriting this file that you have. So if you hit Control Shift S or Command Shift S on a Mac, is anyone using a Mac?
Just read on right now.
Not right now. It is Command Shift S, right? Yeah, okay. Command Shift S will do save as, and I'll just save this as base node, work in progress, V1. Cool. And now you have your original file, and I'm gonna just drag this one, the visual one over here, and just drag it out to the left, and then I'm gonna right click and select them all. If you're on a laptop with no right click and drag, you can hold Shift and then left click and drag to select them all. And by those all, I mean these 4 or these 5. We just want visual 1 as a little placeholder for us. Okay, so we're gonna go into this visual 1 and do the same thing. We're gonna clear most of the stuff in here. So if I zoom out, you can also hit H is a nice shortcut to view your whole network. And it'll frame everything in the level. So if I get lost and I'm like, where is everything? Just hit H and you can find yourself again. And I'm gonna right click and drag and then delete all of these, but make sure to leave this one little out at the end here and all these green ones over here. And so I'm just gonna hit delete. And now we have a black screen, which is fine. And I'm gonna open up the op create dialog, which is tab. And when you hit tab, you'll be greeted with this window that is where you add operators. And operators are what do everything in TouchDesigner. As you can see, there's a whole pile of them. And right now we're at the top-based operator. And so tops are RGBA imagery. And you can think of them as like bitmap images, but it's also good to think of them as just data points. Everything in TouchDesigner is a data point that can be transformed into another form of data. At its core, TouchDesigner is like a data transformation software. And so basically what that means is you can take your audio signal and transform it into whatever other type of data you like, whether that be imagery or a 3D model into the material, and then you can go back again and You can really get endless with these interactions of TouchDesigner. So I will just go over the rest of the families quickly as well. So there's tops, images. Chops are signal-based operators. So this is where we get our audio device in, and our audio files in. And then if you're familiar with like an LFO, we can add that. And it's just like a classic LFO that you have in any kind of software, any kind of music software.
What's an LFO?
LFO is a low frequency oscillator. And so basically it is just a signal that's going left and right, or from 0 to 1, or in this case, -1 to 1. So when you're looking at a waveform and there's a synthesizer, they use LFOs to like modulate the speed at which the waveform is like vibrating to make it sound like higher and lower. It's kind of my understanding. I'm not a musician, so take that with a grain of salt. But you can see it's a sine wave also here. And if you right click, you can hit trail. Also in the op crate dialog, if you type, you can type in which one you want and find exactly. And now you can see this LFO is making a sine wave. And so that's what an LFO does. But you can also change these to a pulse. Now this is just gonna pulse every certain amount of value. But I digress. On to the next operator. I'm gonna delete that. And SOPs are the 3D world in TouchDesigner for now. It is changing with the advent of POPs, which is in the latest experimental version. I unfortunately haven't had time to learn them really, but it'll kind of usurp a lot of these functions in POPs, because POPs are like the answer to SOPs, but SOPs run on your CPU, POPs run on your GPU. GPUs are more optimized these days for 3D design, but for our purposes, the SOPs are going to be great. So that's our 3D format. So we have things like a sphere and a torus, and if I add that, you can see it's a 3D object. All operators in TouchDesigner have this, which is a viewer, and so you can view them directly in their little preview window. Okay, and then I'll go back and just finish this up. We have a material, and so the material is for our SOPs to make them something, to make them look like something. And then we have DATs, and DATs are where kind of the scariest part of TouchDesigner for me is. It's like the programming part, and this is where you can leverage Python to do even crazier stuff. I haven't used it too much, but for example, there's one thing I've done where when I'm doing live visuals, I like to use complex blending modes, but there's only like 10 out of the 25 in the menu that I like. So I've used like a table and made it so that through DATs, I've like eliminated the ones I don't like. That's just an example of what you can do. And then the last special one is comps, and comps are a collection of operators. So we're in a comp right now. Visual 1 is just a base, and a base, again, is kind of like a pre-comp in After Effects or a group in a 3D software. So it's just a container for things. So I can make that and double click and go in, and then U to come out, I to go in, and we can delete that. And then I'm gonna just show you how these chops on the left side are working. So I want you all to, sorry, I just did that without explaining what I was doing. Hit tab and add a noise to our network. So the noise, one of the most valuable tops in my opinion. And this is the basis for a lot of visuals in TouchDesigner, and they can be combined in fun ways and do all sorts of fun things. So I'm just gonna do the core operation in TouchDesigner, which is connecting the nodes together. So if I click from this output and drag it into our out over here, you can see there's this little tail, and as I select it, it's gonna go into our out. It looks a bit stretched, and that would be because the resolution is 256 by 256, and our resolution wants to be 1280 by 720. And so if you go up 2 levels, so U and then U again, we'll get to our main comp where I've stored a parameter that is our resolution so that I can refer to this anywhere in the project, and then it'll update all our resolution across the rest of the system. So what I'm going to do is on this tab, I'm going to right click and hit copy parameter. And then I'm going to go in, and go in again to the visual, again. And then in this resolution, I'm going to hit paste reference. And now this operator is referring to our master resolution. So if I go up again and change this to 720, now our preview is 720 by 720, and this updates instantly. I'm going to leave it like this. But it's always good to have a master resolution somewhere so that you can update and change it on the fly if need be. You never know when your projector might be 1920 by 1200 instead of 1080. It happens. And so the magic of these nodes I've prepared for you over here is how they are going to be able to drive our parameters for us. So there's this one here that's called KSR Speed Audio Up. It's kind of a random name, but it was based on Cook Snare Rhythm, and then I expanded it to also have the low, mid, and high. But I'm gonna just add a null, which is Alt-N is a shortcut you can do, or you can right click and find the null. And it's always good to have a null when you are wanting to bind these parameters to something else in case we want to change the value of this at a later time. And so I'm going to select the noise here, and we're going to actually make it not monochrome because monochrome is boring. I'm going to switch it to Perlin is my favorite noise. Turn the period up to 2, harmonics to 1, harmonics to 1. Yes.
Sorry.
I can, sorry.
So after changing the noise to monochrome or not monochrome, what are the other settings?
Oh, so period around 2, harmonics 1, and harmonic spread also 1. That should be good enough for now.
And then which Berlin? 2D, 3D, or 4D?
4D. I like the 4D. So 4D, I will get into in a moment. If we go to this transform tab at the top here, we have these translate parameters. And so we'll translate our noise in certain directions. So the first one is translate X. So you can see now as I'm modulating it, it's going to the right as I make the number bigger. And then it's going to the left as I make it smaller. And then this is the Y channel. And so we can scroll our visual upwards. And then this is the Z channel. So since it's a 2D animation, the Z is what I like to animate the best because it's just kind of flowing through. As if this is like a slice of noise, it's flowing through that in such a fashion that you're kind of zooming through. So it's not having the up and down effect, it's just kind of flowing through, which I prefer. And then translate 4D is almost the same as that in a way that it's kind of just flowing through the noise in such a way that it's not going left or right, but it is animating. So we're gonna go to this null we made and make our viewer active in the bottom right. And then we have these channels we can play with. And our kick is our kind of most basic channel. It's when the kick happens in the songs. And I'm just going to, once my viewer is active, you can see that these will have highlights and a little arrow. So if I click and drag this and then bring it right to our translate, we can bind the parameter. And so we want it to be chop reference. We'll click that, and now it's animating to our kick, which Paul just played a kick for us. Wow, that was good timing.
So you're dragging the kick into the noise translate 4D.
Correct, yes.
As a chop reference?
Yes,
Okay.
yes. And so I wanted to get to this point to show you that audio reactivity can be a very quick item, and we just need this one noise to make something that is reacting to audio. And so I also just bound the snare to our translate Z, which is this third parameter over here. And now it's responding both to the snare and the kick. And we're gonna step back for a moment to kind of chat about what's happening in this audio tool. So if we go up a level and then go to our audio over here and go in with I, you can see our network. I'm just gonna make this a little smaller for a moment as I talk about this. And so right now I have it set up as my audio device in, which I'm taking the audio signal in from an XLR cable that they ran for me from over there, from the live show. And it's coming into this Focusrite, and the Focusrite is allowing me to read it. And then I have, and it's going into this math, which I'm just averaging the two signals. I don't know why there's two signals. There should just be one, actually. And then it's going into a switch, and this switch I have so that if you, yours is probably set to 1, as it should be, because that's just gonna have the temporary TouchDesigner file in it. Later on, when we open up a little experimentation, we can switch it. You can use your laptop mic, and then like as the sound gets higher in here, a laptop mic is often enough to drive our animations. So continuing on in this network, we have a map. Oh, yeah, go ahead.
Switch that you have, what is it exactly?
So the switch, I have two ins here, right? So this one is our audio device in. This is our live audio, and then this is our audio file in. And the file is just referring to the default TouchDesigner song. So you guys all are probably at 1, and then I know this song so well, unfortunately, that I can see that it's working properly to it. But I would just leave it there for you for now, because you can see the kicks really respond easily to that. It's a very loud, obnoxious audio track.
So if we were wanting to import our own audio, would that be the chunk we put in?
Yes, the audio file in. So if you grab this and hit the little plus here, you can find any song on your computer. I have a collection over here. This is actually who we're listening to right now, Astrolib. But I'm just gonna leave it as the default, because I know the default is always gonna give us those kicks and snares as we expect. You can see as I go down the chain into this audio analysis tool that is built right into TouchDesigner, it's responding very quickly to this song because the song is very loud. Or it's like responding right accurately. But if I go and switch back to our input, since this is the live audio and it's very chill, moody, we're not getting too much action in this audio analysis. So I will continue down the chain. This audio device out is how you can actually preview what you're listening to. My laptop or my computer doesn't have any speakers, so it's kind of useless for me right here. But I have it set so that you can turn the volume up and then you can hear your audio device. There you go, there's the song. And then it goes into a math, and this math is useful to adjust the value of your signal. When you're working with live audio, it's sometimes can be quite unruly, and the signal can be like really big or really small, and so having this easily able to multiply. So you can see now my analysis is kind of reacting more granularly with this soft ambient track we're listening to. I'm gonna leave it at 1 for now, maybe 1.5. And the audio analysis tool is a component that is pre-made and comes from the palette in TouchDesigner. And so the palette in TouchDesigner is this little button in the top left. The other button is the perform mode. Don't click that, we don't want that. You can hit escape if you did click it. But this is the palette, and in the palette we have all sorts of tools. There's this derivative folder, And this is all the built-in stuff that has been made by different TouchDesigner developers over the years and included with the software. Audio analysis lives in tools, and I can drag it out and add it to my network. And then we have the same thing. It is reacting to the default song. And then I just turned on all the channels I wanted in this, which is just those. And now we have basically the same exact thing. So I'm just gonna delete that and close my palette and continue on. So as we go down this chain, this is where the audio is being processed into kind of usable signals for us to drive our animations. I've digested, or I've kind of created this after working in TouchDesigner for a little bit, and I use it for a lot of my projects. You'll see when I show you guys my master VJ setup, almost all the animations are driven from some sort of these nodes at the end here. And I will quickly go into what is happening. And so the first thing is there's a select, and a select is a great operator. If I add one here, I can see that it is selecting every channel that has to offer, that is coming out of this output. And then in this one, I just have the low, mid, and high channel, which is all I want. In this one, I have the kick, snare, rhythm, low, mid, and high. But for now, we're gonna talk about this. And as we go down this chain, I've just selected our low, mid, and high values. And these are the values of like an audio spectrum. So our lows are down here, and then our mids are in the middle, and our highs are up here. And you can change the amount of gain that each of them have in this audio analysis tool. So continuing down the chain, the select is going into an envelope, and an envelope is kind of smoothing out our values a little bit, so it's not as aggressive when the values change. And then it's going into a math, and these two operators are going into this math and then being combined by averaging them together. So the math chop sounds like it can do math. There's all sorts of ways to utilize it. You can combine the chops that are inputted. You can combine the channels into one channel here. You can make the maximum. You can multiply everything. You can rearrange things in here. Very useful. And then it's going into our first kind of out of our first kind of master out of the audio parameter. And so this is a value that's from 0 to 1. And then I have it going into this math, and I'm rearranging it from 1 to 2. I find that in TouchDesigner, there's times where it's very useful to have 0 to 1 and very useful to have 1 to 2. And that's all of why I have it segmented like that. And I can show you a quick example with our noise, our passive noise that's happening here. If I split this panel one more time with this top right tool arrow, we will split it left and right, and then zoom out and zoom back into our visual. And then you can see that these chops in here are basically just selects of all of these. And so in every visual, I will have a select of these core chops of audio so that I can drive each visual from the same base audio breakdown. So this low, mid, and high channel that we have here, I'm gonna create a null, Alt-N, to create that, and then I will pipe it into the noise amplitude. And we'll see as I put that in, we're not getting very many lows, but maybe I'll turn up our signal a bit. And now, as the lows come in, come on, Paul, it'll make it react and colorful. So if I drop the offset down, the offset in a noise is kind of our medium value. So if it's at 0.5, it's going to be gray. If it's at 1, it's going to be white. If at 0, it's going to be black. And so you can see that right away I'm using this amplitude value to try to use our lows to make it reactive. And it's a bit aggressive, it's a bit fast for me. So one of the things we can do is insert another operator, add a lag here. My A button is broken, excuse me. It just double presses for some reason. And this will smooth it out a little bit. And yeah, I'm gonna go back to chatting about the rest of this audio component. I was just checking the time. And so we have that, and I showed you how this one is translating through our noise. And how we arrived at this value is we're taking our channels, our kick, snare, and rhythm, feeding them into a lag so that they're a float value instead of an integer value for the case of a kick, snare, and rhythm. An integer just means that there is only, there's no decimal points in this value. It's just a 0 to 1, and we want decimal points for this. So a lag will help us fix that. Then it's going into a math, and the math is adding a little bit of value to this constantly, so that when I'm gonna go up and into our visual again, just so I can explain this better. I'm gonna delete this also because it'll be more conducive to this part. So if we look at this, we have a constant kind of animation, and that's because of this pre-add of 0.1. If I take away that 0.1, it's going to be static until a kick or snare is detected, which I think is less smooth. So I usually use the pre-add, but you might want to have this. And so our pre-add is making it have a constant value, and then this speed chop is taking our value and adding it to accumulate the value over time, so that we're getting a greater and greater value, which is driving the translation in the noise, so that it's always iterating into something new, and it should be infinite in theory. And this is kind of one of the core things of generative visuals I use a lot, is driving noise with this kind of audio breakdown. Moving on to this next chain of operators down here, it's a very similar concept. It's just more built for a rotational operator. So we're gonna go into like orbiting around an object with a camera at some point, and this is the channel we're gonna use. Down here is what I like to call a kick snare flip-flop. And so basically every time a kick or snare happens, or a rhythm, it's going from -1 to 1. And it's flip-flopping back and forth, which we will see is useful in certain parameters down the road. And then our last one, well, there's two more. Our second last one is a classic spectrum. So we have our initial waveform coming in, which is a cool little waveform and can be used for animations as well. But generally a lot of people like to use the audio spectrum, which turns it into this classic kind of spectrum look. And we will try to get to processing that a bit later into a visual. And our last thing in this audio component is very simple envelope. So this is basically an envelope is something that will smooth out the values, but it will also kind of keep it. If it's the snare's constantly going, you can see that it's kind of staying at 1. And that's different than a lag. A lag will just kind of slow it down. I have both here, but this is used for, I just use it sometimes. I don't know. I like to have this set of operations available to me, and then as I build the visuals, you kind of get familiar with these and what they're able to do. and we can process them later and break them down further. So now that we have talked about that, we will get into building that first example. Do we want to take a break now, or do we want to continue on for 10 more minutes?
Keep going.
Keep going? Okay. My voice is getting tired.
Oh, sorry.
I practiced like for this for like 2 hours today.
I feel like you have the ultimate say. If you want to take a break, it's okay.
No, it's chill. I just I planned in a break at around an hour mark, so this is a stopping point. But why don't we try to get through a visual? How's everyone finding the pacing? I know it's quite fast, but it's short. We only have 2 hours. This program is dense. Okay. So we're gonna make that torus scene that we saw initially. And we'll leave this visual for now. And we'll start talking about how to set up a render network and create a 3D object. So if we hit tab, and you can do tab to go through all these operators, we're gonna wanna grab a SOP. And in the SOPs, like I said, they're 3D objects. And what I want is a torus. So let's add our torus to our network. It's just a simple donut shape. I'm clicking the viewer active down here to see what's going on.
Should we delete the previous noise stuff that we did?
No, you can leave that. We're gonna reuse it actually
Okay.
for another parameter down the road. And it's also nice to just have something that's not blank. So in TouchDesigner,
Whole map looks like.
sorry?
Can I see what your whole map looks like so far?
That's it. Yeah, I mean, if you're, you could have this blank at this point too. We're just gonna reuse this noise slightly in a creative way. So on the torus, I'm gonna add a null, Alt-N, and then I'm gonna right click, and we're gonna add a special comp to it, which is called the geometry comp. And so if we wanna see our geometry in a render, we kind of need a geo comp. And the geo will hold our object, and this is what allows the TouchDesigner to render. And the geo needs a few other operators to work properly. We need a top that's called render. So the render top does what it says, it's rendering this geo, although we have this because there is no camera. So we're gonna add another comp, tab, and go to the comps, and then just add our camera here. And so now if you zoom in on your render, you see we have this torus. And at this point, I will overtake our noise that we have. And so if you click and drag out, and then drag over the line, you can see it turns yellow, and that means we can overtake that route and make it our primary out. So you can see there is the torus. Does not look very pretty at all right now. And that's because there's no material on it. So let's add a material. Tab, and then material. And for now, I'll just add a Phong material. I'm not gonna go into what each of these are because they're complicated. And we're not even gonna use this as our final material anyway. I just wanted to show you. And then,
Can you do that again?
Yeah.
The material.
Phong. So once I add the material, I want to assign it to our geo by clicking and dragging, and then there's parm, so this means to match it to the material and make our material. And now you can see it's black, which is not what we want, and that's because there's no light in our scene, and a Phong material needs a light, so we can just add a light as well here, and it'll automatically render with this light now. So now we have this torus that has material and camera. And this is what is the basis of rendering 3D objects in TouchDesigner. you will kind of always need a camera, a geo, a render, a light, and a material to do this. And so what we're gonna do to make this kind of that wireframe look I had before is we're gonna change the material to a line material. And the line material will create wireframes for us. And I will bind it to the geo again, which is here, and hit material. And then we have, hello. And we have the line material now represented on our torus. What I also wanted to do was add a point to it, and we'll just multiply this point size a bit so we can see them in our network. And so now we have our base structure. This is kind of getting close to what we had before. I'm gonna go over to my camera and adjust a few settings. For me, I like to change the FOV to make it look a little funkier. And I'm also we're gonna animate this camera with our audio signal. So to do that, let's reset every parameter in this camera op, or in this camera comp, by right-clicking and hitting reset all parameters. So now we are at the center of our scene. The camera is at 0, 0, 0, and we want it to be -5. And I realized I never told you about how this shortcut works. So to change these values quickly, if you have a mouse, you can middle click and then change the values by going left and right. If you're on a laptop with no middle click, you can left click and hold and do the same thing. It's one of the best ways to quickly change values in your parameters. So I'll leave it at about 5 for now. And now I'm gonna make another comp called a null so that I can connect these two together to make it move. So that was tab, and then to the composition tab, and then click a null. And so this null will rename parent, and we want it to be the parent of our camera so that we can control our camera with audio. And so if you drag out from these little two port here into the port down here, we now have parented our null. And a null is kind of just a placeholder. If you guys are familiar with a lot of softwares have nulls, and they kind of are just like a reference or a place to store information, or I don't know, they're hard to explain. But this null is right at the 0, 0, 0 in our scene, and our camera is at 5 degrees on the Z, 5 value on the Z axis. So if I go into this parent and click the middle button and then drag it around, you can see now we are orbiting around in the X axis. And it works for all of these axes we're on. And so to make this audio-reactive, all we need to do is grab our chop data from over here. And this is the noise driver that I was talking about. I'm actually gonna hit 1, which is set up to be a reset for everyone here because that value is a bit high. And I'm gonna hit Alt-N to bring out a null. And now we can refer by making the viewer active and going to the parent, and then we're gonna drag in our kick to our rotation channel in the X. So now the kick is driving our rotation channel in the X. And then I'm gonna do the snare in the Y, and then the rhythm in the Z. So now each of these audio channels is controlling one of the rotation channels.
What if mine isn't moving?
Yours isn't moving.
Something to do with
It's because you're using the wrong one. Yeah. You're using the noise one. And for me, this is a bit aggressive. So I'm gonna add a math in between these two to make a fraction of our signal and make it smaller. So you can just right click in between each node to add extra operators. So right click, insert operator. You can also right click right at the edge of one to do the same effect. So in this math, I'm just gonna pull it down to about 0.2 maybe works for me. Yeah, that looks pretty nice to me. I'm gonna also go into my camera and just pull out our Z a bit more, give it a bit more room to breathe. And then next up, we're gonna do just a little bit of post-processing, I think. And what we're gonna do is make a little blur happen with our Luma blur. So I'm gonna right click again in between these two operators, and insert operator, and type in Luma, and we will find this Luma blur top. And so it's not doing anything because it needs a black and white value to blur based on the black and white map of the top that we're gonna make in a second. So I'm gonna hit tab and we're just gonna make a new top from scratch, and we're gonna make a ramp. And a ramp is like a gradient, which you may be familiar with from other softwares. And this will allow us to use the Luma blur in such a way that we can control where our blur is. But the first thing I want to do is make this 1920 by 1080, or sorry, 1280 by 720. So we're gonna go up 2 channels, U and U, and copy our resolution, copy parameter, and then in 2 channels, and we're gonna paste this here as a reference. And while I remember, our render is actually already set to 1280 by 720 by default, but we're gonna update that too, just in case we want to change it at another date. So we'll paste the reference there too. Now we have both are matching, and I'm gonna drag this ramp into our Luma blur. And as you can see, we have a blur happening kind of on the right-hand side and not the left-hand side. And that's because this is going left to right. So if I bring this to the middle, we can see that now the middle is not blurred and the left and right side are. What I'm gonna do though is change this to a circular version, and I'm gonna pull this back to the left. So we're back at the base, and then I'm gonna extend left to hold and hold. And now we have just a black circle in the middle. And where it's black is where it's not blurring, and where it's white is where it's blurring more. So if we line this up right here, you can kind of tell what's going on with this blur. Maybe if I make the white filter really aggressive, you can see that it's blurring out the edges. And so maybe I'll pull this phase up a bit to make our black circle a little bigger. I like to switch it to Hermite, which will interpolate it in a non-linear way. It's kind of like using an ease in After Effects, but in this ramp. Great, and so that's our first little post-processing that I wanted to do to give it a blur, add some sense of depth to it. And I think now we should take the break, because
Save your file.
Oh yes, good call, Greg, with the tip, save your file. I actually had an autosave function in here that I was gonna, or I stole one from the site. Okay. I'm gonna stand up and walk around for a second. let's meet back in 5 to 10 minutes, everyone.
Shouldn't do that.
Okay, welcome back, everyone. Now we're gonna take this torus and we're gonna transform it into being able to be affected by a noise in such a way through top-based data instead of 3D data, because it's much more efficient on our computers, and it's a good example of how we can transform data in the software into different formats and then back again. So this might get a bit confusing, but bear with me. Hopefully you'll glean some information. I'm gonna just organize my network a little bit more by dragging everything. I'm gonna leave this torus over here alone. And I also just hid the viewers. So if this button, you can toggle your viewers to be active or inactive. And they actually use up a lot of resource in TouchDesigner. So if you're struggling a bit, turning those off can give you sometimes all the boost you need to get back to 60 frames a second. So we're going to transform this torus into a chop. And how we're going to do that is we're going to middle click on the output here. If you are on a laptop with no mouse, you can right click and it actually will do the same thing in this case. And we're going to hit the chop over here and we're going to go SOP to chop. And so now we have our SOP into chop format, and we can see it's represented as these waveforms. But we're not done yet. We're gonna add a null here in case we wanted to modify anything within this network. And for example, I'm gonna just show you that it's gonna basically be the exact same structure if I make it into a chop again from this SOP. So if I right click here and go to the SOP and then hit chop 2 again, we will have our donut again represented. And I will just drag this into our network. And you can see it's almost the same structure. There are a few differences that you can notice. We lose some of the wireframeness around the edge just because of the way the data is being processed. But it's fine for now. I still like how it looks. There are ways around that, but this is just an intro, so we're gonna not go into that for now. I'm gonna transform the data from a SOP further into a top. And so if I right click and on the end of the SOP and go to the top and then hit chop 2, now we have an image-based version of this data, or an RGBA version. So if I go, we only have 3 channels in here, so I'll just do RGB. Sometimes you'll have an A channel. And now it is set to rows per channel set cropped. So that means each row in this top, if I go to display pixel values, I guess this just strings it out into one long data set. Usually I like to work with it in fit to square, but one of the issues with fit to square is these transparent pixels up here will cause some unwanted points in our final image or final SOP, but I'll show you what I mean. So we have this chop 2. I'm gonna add another null because we're definitely gonna add something in between here. And then I'm gonna right click and go back to a chop and go top 2. And now you can see in this top, it seems a lot more limited in data than this one over here. And that's because it's only gathering our row U. So it's only grabbing one row of the like horizontal value, left to right. The V would be up and down, and the U is left to right. So we want to make sure that we're capturing our whole image. And first we're going to do output as a single channel set down here. And this is a very important function. Otherwise you'll end up with a whole bunch of channels per row, and that's not what we want in this circumstance. So make sure that is set. It's also kind of a resource intensive moment in this software, especially if this is off, because it's going to create a whole bunch of channels. So we want that on, and then we go to the crop and we do full image here. Now you can see that this is almost the exact same. Well, it is the exact same, except for our little alpha channels issue. And now that we have that top, we're gonna add one more null. And instead of having our chop back here to the chop to, we're gonna modify this chop to by clicking and dragging this null on top, and we get an error. That error is because our channel scope is set to TX, TY, and TZ, which are the values that it's expecting from a SOP. So you can see here, it has the values of TX, TY, and TZ. But once we get it into an image, they transform into RGB values. And so there's a few ways around this. The easiest way for me is just to rename the channels in this channel scope parameter here. And we can rename them R, G, and B. And now we have this structure back again. The one issue we have with this structure now is this middle point here. And that's because of these transparent pixels in this top over here. So the easiest way to fix this for us is just to change this back to rows per channel set cropped. It's harder to see what's going on in our top when it's like this, but we don't have that issue. And the other way you can do it is like add a crop. Piquetta 12 at TouchDesigner Legend has taught me how to do it once, where it's perfect, but I can't remember how to do that. So we're just gonna keep it to rows per channel set. And now the whole point of doing this is so that we have the data in RGBA format to play with some format files, to play with how this is represented. And what we're gonna do is run this through a top base noise. So if we right click in between here, insert the operator and type in noise and add it, you'll see that now our shape is being affected, and it's being affected by this noise and being displaced by it. And so if we pipe in down here, it's going to use this as an input for the coordinate map. It's kind of hard to explain what's happening, but it'll just look better. So I would do that for now. And this offset is kind of where our 0 value is. So if we want it to be orbiting around that center null we created earlier, we want it to be at 0. And for me, the amplitude is quite high. So I'm going to lower it down a bit. And then I'm gonna also change it to Perlin, my favorite. And I might lower the period a bit. It doesn't have to be too exact. The period will make it kind of like more complex. It's like a bigger or smaller wave of the noise. And so as I increase it, you can see that it's just kind of being a bigger displacement. And as I lower it, we're gonna get kind of more detail in our displacement of these points. And so now that we have this transform, we can do what we did earlier, and we can run our kick channel through the noise parameters. So if we grab this null 1 kick, and it's already active, we can click and drag and bind it to the translate 4D by hitting chop reference. And now our kick is driving how we're translating through this noise, and it's being affected by the audio. So I'm gonna click and drag the snare as well to our Z, and that's gonna be a bit faster. There's usually more snares in music, so I often will just go into this value. And any parameter in TouchDesigner You can use basic math or complicated math or Python code to affect it in all sorts of ways. All I want to do right now is multiply this by 0.1, making it 1/10 of the strength. So if you type in star and then 0.1, we will effectively lower the speed at which it's going through that. And so now we have this weird, funky little audio-reactive torus. We're getting pretty close to the example that I had. One of the last things I'm going to do is show how we can use this amplitude to really make it react to some values. And so I'm going to go back to our low, mid, high over here, and I'll middle click to create a new string of operators, and I'm gonna add a math. And in this math, I'm going to combine all these channels together so that we have kind of a master value for our low, mid, and high. And since they're all being added together, this kind of captures the whole song or the whole audio track as you're listening to it. I'm just gonna turn down our audio input a bit. And you can see that we are going from about 0 to 2.5, 3. And one of the very useful things in the math chop is the range function. And so our from range is the value that is being taken in. And so right now it's set to 0 to 1, and our out range is 0 to 1. But if we look here, we kind of have it going up to around 3. So if I type in 3 in our from range where the 1 is, now it's going from 0 to 3 and rearranging it into a value between 0 and 1. And I think I actually will probably want a little less because we're going to bind this to the amplitude and the noise. So I'm going to just drag this down to about 0.5. And now I'm going to add a null in case we want to change anything. We're going to make this viewer active, and we're going to go to our noise here and put this right into the amplitude over here. And so now we get it reacting quite a lot to our amplitude of the song. I'm gonna just lower this down, and I'm gonna add also a lag in between this math and the initial chop. So if I right click here and add a lag, we're going to smooth out those signals a bit so that they're not quite as jumpy. And I can turn up my DAC over here and see it react a bit more to our music. And then one of the last things I did for this animation was to animate our camera a bit. And for that, we're gonna animate our FOV angle. So if you go into our camera and go to the View tab, our FOV is, if you're familiar with video games, this is the FOV slider. So, and if you're familiar with cameras, it's how cameras work. The FOV kind of will be like a zoom in and out, but it's a little more complicated than that. Like a wide FOV angle will make things appear bigger in some circumstances, and a lower one is kind of gonna flatten them out a bit. So a telephoto lens is usually a pretty small FOV, and then like a ultra wide lens is a higher FOV. So I'm gonna kind of just pick some ranges because I want this to react to as our audio is going in and out. So maybe we'll start around 48 and go into like 77. And so we're just gonna go and copy and paste these two nodes that we have over here. So right click and click and drag, Control C, Control V. And now we're gonna rearrange this to those values around. So around 40 to 70 in here. If you hit tab, it'll go between these two. a quick way to modulate both values. Then again, I'm going to make this viewer active by clicking the star in the bottom right. If I click and drag, we can now go and zoom out and find our camera. And if we hold it over the camera, it'll pop up our parameters window. And then we can put it right into this FOV angle. So now our FOV is responding to the audio.
Did you put the null in the FOV?
Yes, I did null 9 over here. You missed the step where we rearranged it into. So if you copy and paste these two, this one and that one, and then in the math here, turn that the range from like 40 to 70, and then pipe that into our FOV. No worries. And this is almost it. The last thing I think I did was add a bit of color to our points, and that's why I left this noise down here from earlier. We can use this to drive our color values in the points. And how I'm gonna do that is I'm gonna lower our resolution of this to just to be 1 by 1. And now if we zoom in, we just have one color in here, and it gets a bit dark. So I'm gonna bring this offset back up to 0.5. In a noise, the offset, if the offset and amplitude is 0.5, it'll be a value from 0 to 1, which is what we are desiring in this time. And then I'm going to transform this noise into a chop so that I can refer to it. So I just right click here, click on the chop, top 2, and we get our colors in a value, an RGB value. And we'll take those RGB values and find our material, so our line material over here. And we're gonna make our points the color of this noise. And so all we have to do is make the viewer active, click and drag, and then we're gonna put the R in this first one, which is our R parameter. You can see our parameters actually are cut off a bit, but maybe if I extend it, nope. This one's R, this one's G, and this one's B. It's how it is in the whole software. And so I'm gonna go G into the green channel, and B into the blue channel. And now we have our points being changing to this noise. I'm also gonna make it so that the far color and the near color match. This is a setting in this material so that you can change the colors between the near and distance if you want, but I want them to be the same. So we can right click, copy parameter, and paste reference. And now it's referring the point near color, sorry, the point far color is referring to this parameter, and it's matched. And this was basically the whole first animation, and it's 9:40, so we're gonna go on to the next one real quick, since we're running out of time very ASAP. So I might speed up a little bit. I'm sorry that this has been quite fast-paced. It's not a very long time to learn this very complicated software, but I'm hoping that you're learning something. So we're gonna just copy and paste this entire visual one. So Control-C, Control-V, and we're gonna take this and put it into the 2 switches I have here. So if you highlight both of these by right-clicking and dragging, or shift-clicking, and then clicking and dragging from our out into either one, actually, it'll bring it into both. And this is just a simple mixer component I built for you guys. And if you look at this switch 1, it's gonna be 0, and switch 2 is at 1. So that means our second input is toggled in our second switch. But in here, we have our A deck and our B deck. And so we can switch between the two, but they are the exact same right now. But if I leave it at B and go in here, and we're gonna start from almost scratch again. Let's just leave this one noise actually. So let's leave the noise and delete everything and delete. Are we gonna leave, maybe let's leave this one that's referring to the noise. Let's delete everything else. And we're gonna pipe this back into our out over here. And we're gonna update the resolution again to match. So we're gonna go up, and we're gonna copy the parameter and then in, I, and paste the reference in here. So now we're back at this noise being animated by our music. And I wanted to show you guys a quick feedback loop, reaction diffusion. For that, I want this to be monochrome. And so I just click this to make it monochrome. And then we are going to create a feedback loop and make it kind of a reaction diffusion formula. And reaction diffusion is based on like this algorithm by Alan Turing, I believe. He like invented Turing pattern, or not invent, discovered Turing patterns, I guess. And Turing patterns are like something that's represented in nature by like zebra stripes and whatever. And this is a way to kind of make them in TouchDesigner. So I'm gonna right click here and I'm gonna add a null for our feedback start. To be organized, we can just type in feedback start and rename our null. And then I'm gonna add a new chain by middle clicking and hitting middle clicking the out to add a new chain and adding a feedback. So now that we have this feedback, I'm going to add some operators in a chain to it. And one of the cool shortcuts I've learned in TouchDesigner is that if you hold shift and add operators, and click on the operators, you can add them in a line without ever leaving the op create dialog. So if you know your kind of formula of operators, you can all add them at once. So what I'm gonna do is hold shift, find our limit, click limit, and you can see it added it. And then I'm going to add a blur, so shift blur, blur again. We're gonna try to find our subtract. If you're struggling, you can always type in to find it and it'll still work with our shift. And then we're gonna add a math, and then we're gonna click out, and now we have the basis for our feedback loop. And then I'm just gonna add a null at the end and call this feedback end, FB end. And to make the feedback loop actually feedback on itself, we have to drag and drop this onto feedback, and it should update automatically. Nothing really is gonna happen because we need to modify our chain a bit.
Question, sorry. So
Oh yeah, for sure.
feedback, what did you drag back for the feedback?
You drag the end, so our final null
Yeah.
after the math, we just drag it onto the feedback,
Okay.
and it'll make this the target top. And so what this is doing is our target top is essentially taking the final frame or the frame and then bringing it back into the feedback for the next frame and continuing on. So this is how you can create really, really funky effects. And it's one of the core magic things in the software is to utilize the feedback loops. They are really hard to wrap your head around initially and very hard to explain, but once you kind of start working with them, you kind of can figure out what's going on a bit more. So to finish our little feedback recipe we have for reaction diffusion, I'm going to take our second blur and we're going to Control X. So we're going to cut it out of the project and Control V, and that will give us it in a separate line. And then we're going to bring that into our subtract. And now our blurs are being subtracted by each other, which is the core basis for reaction diffusion. Our second blur should have a higher filter size than our first blur, so I'm going to just bring this up to 8. and our math needs to multiply it by about 7.5 is a good value. And nothing is going to happen. But if I hit 1, we can see something happens for 1 second. And that's because we need to limit our values because they're going into insane amounts right now. But if we go into our limit and we limit our max to -1 and our minimum to -1 by adding these clamp parameters and then hitting 1, we should start to see something. But I wonder if I forgot to do yeah, I think that's why. So all operators or all tops in TouchDesigner can be in many pixel formats. When it's an 8-bit fixed, it means that it's kind of a fixed format from 0 to 1. But if we switch it to 16-bit float or 32-bit float, then our values can be kind of anything they want. So greater or less than 1, and this should fix it. It is not. Oh, because our math is only at 1.75. It should be around like 7, and that should fix it, yes. So now, if I take this and pipe it in, we get a very cool pattern. This is a feedback, a reaction diffusion pattern. If you guys hit 1, it should be all able to reset. I have this function store, TouchDesigner Legend function store has created this, and it's a reset, master reset that kind of can reset everything you want. To quickly make this audio-reactive, since we're really running out of time, I'm going to add a displace in our feedback loop. So we're going to insert the operator and type in displace, and add it here. And once we have this, we need to displace this with something. So we're going to displace it with our initial noise. And so we want to create a new operator thread as well with the noise by middle clicking here. And then we're going to take what's called a slope of this. And the slope is going to give us red and blue values by default based on what is moving. And so if I increase this quite a lot, you can start to see the red and blue values, and they match up with our noise over here. And so we want that because that's what a displace is expecting. And I changed this 0 point quickly, you might have missed it, to 0. And I'm going to change our strength back to 1 because it's probably going to be quite a bit in this feedback. And so this 0 point should be 0, and this source midpoint should be 0 as well. It could also both be 0.5. I just prefer to have them as 0. And then if we click and drag our slope into the displace, we'll see that it starts displacing our pattern based on kind of how this noise is animating. And so we can increase our strength and it goes pretty crazy. We can lower it. And one of the quick things we can do right now to animate is just grab this low, medium, and high chop over here. And this one is the one that goes from 1 to 2. This is why I said I like it sometimes to go from 1 to 2. And if I add it to our strength, now our kick is kind of making it go faster or slower. And then I could grab our mid and I could take it over to our displace and put it in the displace over here. And now our mid is controlling the displace amount, and our our low is controlling the strength of the slope, and together they're kind of oscillating the speed at which it's being displaced. Another quick tip is just to change this instead of hold to mirror. It'll kind of smooth things out a bit. And then I like to blur it out because this is quite an aggressive pattern. If we just add a blur, it is going to make it a little more kind on your eyes. And yeah, that's a quick little way to make an audio-reactive reaction to diffusion animation. Another really fast thing you can do to modulate it is add a transform right at the start of our feedback. So if we go in here and add a transform, we can make it spin. So if I add 1, it's going to make it rotate quite a lot. But if I lower it to like a 0.1, might be a nice chill spiral. We can also take this KSR flip-flop that I have down here and maybe pipe it in here and then times that by our value of 0.1. And then when a kick does happen, it'll switch the direction of which way it's rotating. So basically, what I want you to take from this workshop is that all these values can drive whatever you want in TouchDesigner in all sorts of creative ways. And it can be a pretty simple network to get quite complicated results. And basically, with this amount, or with just a small bit of audio processing, your options are really endless. And yeah, I hope you learned something. I think we're running out of time, so I was gonna open up my VJ file and kind of show you what is possible. And then we can start plugging in your laptops too, if you guys have anything you want to display and play with. And yeah, I'm gonna save this just as our work in progress file, and I'm gonna show you my VJ setup. I have it on my desktop.